AB Calculus Note Card 5, Limits to Infinity Analytically. This is the fifth in the series of AB Calculus Note Cards, which was developed by Stacy McMullen, formerly of the Dallas Independent School District. I attended some training sessions with Stacy over summers and also co-taught with one of her associates, Tracy Etheridge. Okay, here it is, limits to infinity analytically, and here we have the concepts here. If the degree of the denominator, and we're talking about polynomial functions on the numerator and denominator, then the limit is the ratio of coefficients of the highest degree or highest power, and that's called BETC. So it means bottom equals top, use coefficient. And that's going to be maybe the most common of them all. B, if the degree or number is less than the degree of the denominator, then the limit is 0. And we're talking about limits as x approaches infinity. Okay, we're talking about limits to infinity. Or limit as x approaches negative infinity of f of x. And if there is a limit, that limit becomes the horizontal asymptote. Okay, C, if the degree of numerator is greater than the degree that's in the denominator, then that limit does not exist. And that would be BOTU. And so it may seem kind of trite, these acronyms, but they really do help the students to get a better idea of what's going on. And then here we have another case, other functions, then consider size of the function. And logarithmic function is going to be smaller than a polynomial function, which is going to be smaller than an exponential function. And you have to consider negatives and so forth. And so now we're going to go to the application of these principles in 7 problems, the first 5 of which are here. And we're going to go ahead and scroll back and see what's going on. So we look and we have limits to infinity. Okay, now if you don't have limits to infinity, if you have limits to a certain number, you're going back to note card 2, I believe, which is just called limits. And so what you do is you look and you have polynomials on both the numerator and denominator here, and you have the powers are the same. Okay, so our answer is going to be the coefficients of these terms here, these highest terms. And so what we're going to get is 4, because we have 4n squared over 1n squared, which equals 4. And that's really all there is to it. So this is BETC, bottom equals top, use coefficient. Okay, so that's how I draw it. Bottom equals top, BETC. Next, 2. We have limits x approaches infinity, and here we have a polynomial divided by a polynomial, and we have 2x to the first power, and then down here in the denominator we have 3x to the square, to the second power. And for that, we look at, okay, we're going to look at bigger on bottom because we have 2 is greater than 1, which means we have bigger on bottom, and so what we have is 0. And what this means practically is the farther we go toward infinity, whatever is in the numerator is going to be washed out and overwhelmed by what's in the denominator, and hence we're going to converge to 0. Okay, 3. And here we have, again, a polynomial divided by a polynomial, and we have a 5th power in the numerator and a 2nd power in the denominator. And so what does that translate to? Well, we have a bigger on top situation because 5 is bigger than 2, so we say limit as x approaches infinity of f of x, we consider that, does not exist. Now, I'd like to encourage you to resist the temptation to not put equals does not exist, because an equal sign is a verb, just like the word does is a verb. Okay, 4. The limit is n approaches infinity of 7n to the 4th power plus 500 over 3 to the n. In this case, we have a polynomial up here. Okay, polynomial divided by an exponential. And for that, we're going to come back and say, well, this is the case here. A logarithmic is smaller than a polynomial, which is smaller than an exponential. And so what this means is we are bigger on bottom. So that's going to be a BOTU, a BOBO situation, bigger on bottom equal to 0. So our answer to this limit to infinity, is going to be 0, because whatever's in the numerator is going to be overwhelmed as we approach infinity by what's in the denominator. Next, 5. Limit as x approaches negative infinity of 6 to the power of 1 over x. And this is one where you really take some conceptual understanding of what's going on. What's going to happen as x becomes smaller and smaller towards infinity? Okay, we're going to have 1. If we put in a million, right? If we go to negative a million over negative 1 million, right? You can just use bigger numbers as a thought experiment. So if we have 6 to the power of this, it's going to be very close to 6 to the power of 0, right? You can see that this is getting closer and closer to 0 from the negative side. And 6 to the power of 0 equals 1. And so therefore, as x approaches negative infinity, this value of this function is going to approach 1. And so our answer to this is 1. Okay, so a little thinking involved in some of these. Always think. Next, 6. Okay, now these asterisks mean that these were actual problems on AP tests. If the graph of y equals ax plus b over x plus c has a horizontal asymptote, y equals 2, and a vertical asymptote of x equals negative 3, then a plus c equals. Okay, what you're going to have is you're going to have to divide by 0 to get a vertical asymptote. So if we say x plus 3, or excuse me, x plus c equals 0, and we're told that we have a vertical asymptote where x equals 3, then negative 3 plus c is equal to 0. Well, if we go ahead and solve for c, we know that c is equal to 3. Okay, so we want a plus c, and we know we have a horizontal asymptote y equals 2, and we have x down here. So to have a horizontal asymptote of y equals 2, using the principle here we talked about BETC, bottom equals top, use coefficient, right? So what that means is that a is going to have to be 2, because then we'd have x to the first power 2x to the first power divided by x to the first power. And so a would have to equal 2. And so therefore, a plus c equals 2 plus 3 is equal to 5. So 5 would be our answer here. So it really takes some piecing together, some detective work to work this type of problem out. Now find number 7. For x is greater than or equal to 0, the horizontal line y equals 2 is an asymptote for the graph of the function f. And a y equals function is what kind of asymptote? It's a horizontal asymptote. So I'm just gonna abbreviate horizontal up here. It's a horizontal asymptote. Which of the statements below must be true? Well, f of 0 equals 2. Well, not necessarily. Right? In fact, the function can actually be defined at f of 0. We're interested in the limit as x approaches infinity, or I'll say plus or minus infinity of f of x. And so, let's see, so that's not right. F of x is not equal to 2 for x is greater than or equal to 0. Well, the thing actually could equal 2. Often it does not. F of 2 is undefined. Well, we actually could be defined. Limit as x approaches 2. Well, what it is, that's Notecard 2, limits to a certain number. Well, we have, our answer choice is E, because a horizontal asymptote is defined by limits to infinity. So there we are with a few problems. BETC, BOBO, BOTU, very helpful technique in understanding and being able to describe what's going on. Take care. Thanks for viewing.